you guys were here in the last class. You all were here in the last class, so why are you? Why you guys keeping quiet? Fantastic. So we say that if you have two functions multiplying each other, what do I say? You see, this boy say he did it. I will need to go and crop this thing now. Oh, it's okay like this now. I think it's okay like this. Who still needs the course content? You want to snap? I think it's okay. Right? You have it, Kari? Good. So if you have these integrals to work with, you must use the concept of integration by what? By parts. And I told you guys that the only way you can integrate these two, you know this is two variables together. Two functions rather. You have x here and you have what? Exponential x. What about here? Here what do you have? You have ln x and you have what? You have ln x and a function, and what do you have again? Huh? You have 1. There's a 1 here. Isn't that so? What about here? You have tan inverse of x. Let me see if there's a... Okay. So what do you have again? You still have 1 as the function. Is that also? Is that also? And then you have here what? X squared as another function. While here you have what? Exponential x as a function. Now, the idea is that from the concept of product rule, you remember product rule when we are treating differentiation? Product rule. From product rule, that is where we derive the formula for integration by parts. So let's try and derive it again, right? When you have two functions, u dv, you have two functions, uv, right? And you want to differentiate this thing with respect to what? You want to differentiate it with respect to what? Dx. So if I want to differentiate this with respect to what? Dx. Which is the same thing as what? UV prime. Is that not so? Good. I told you guys the representation is because of Newton and who? Leibniz. They did this thing independent. So we say we have what? We're going to have U dV upon what? Dx plus what? V du upon what? Dx. Is that what we are doing? Yes. So if that's the case, what else are we? What else here? From that particular function, what can we see? We can see that, of course, I can move all these guys to the other side. I can move this animal here to this other side. If I cross multiply, I have if I differentiate this guy, I can move this dx to the other side. So I have uv upon dx plus v du upon dx. Is that also? But here, I'm taking this guy to the other side, so the x will be here. Is that not so? Fantastic. And if I want to take the integral of this side, automatically I can have the integral of this side also. Is that not so? Good. And I told you guys that since you have addition or subtraction separating these two concepts, I can integrate them individually. Is that what we agree? Yes. So I can decide when I integrate this function, I'm just going to have uv. Why this part? I'm going to be having the integral of u dv upon what? dx. Let's open it. So I have the x over here. Plus, I can integrate it separately. Integrate. What will I have? V. Then I have what? u upon what? dx. My dx will remain here. That also? Fantastic. I think this can go, these two can go. So I have uv should be equal to what? Integral of u dv, right? Plus what? Integral of v, then what? du. Are we together? Are we together? Fantastic. So I want this du dv to be on its own. I can move this guy to this other side. So I have uv. If I move this positive sign across the equation, it will be what? So I have minus integral of what? V du. So this is going to give me what? Integral of u what? dv. Are we together? So this automatically becomes the formula for what? Integration by part. So we can take it up here. Let's take it up here because I'm going to clean out this part of the function. This part of the blood rather, then we're going to be solving this. Are we together? So what is our formula? Somebody should call it for me. Our formula is what? Integral of u dv should be equal to what? uv minus integral of what? v du. Any confusion? Are you confused? Are you confused? So the idea is from your concept of production to allotment. So when you have these two multiplying each other, then it's very simple. I'm going to take one, differentiate the other, plus differentiate the other, and keep the other one, which we have done over here. Right? Then we integrate both sides. We got uv on this side. Then what we have here is we are just trying to extract this particular function, u dv. Right? Now, we will now use this particular formula to solve all these integrals. The formula is what? No. Integral of u dv is equal to uv minus integral of v du. Now, consider this function over here. The function here is integral of x exponential x dx. Can you see that? Can you see this? So, if you look at this, we can compare it with that particular formula over here. Can you see? We have dv. So we can take this to be our what? U. Can you see that? U. And then the whole of this function will be what? dv. Are we together? Are we together? We can take this function to be u and take this function to be what? dv. And I told you guys before that multiplication is what? Multiplication is what? Is commutative. Which means if I say x exponential x is the same thing as what? Exponential x multiplied by what? X. Is that not so? So if you are given this question in this form, you should change it to this form. But I'm going to be giving you the guideline, which one you should always take as your u. You understand? If you have two functions together, which one should you take as your u? If you're done with this part, I'm going to take it off. If you're done with this part, I want to take it off. Can I take it off? Huh? I can now. Okay. So take the formula here. If you are not done, take it from any of your friends. So what we have over here, so I'm going to let what? X to be equal to what? Talk to me now. This is the function. How will you say you are not seeing it? Is this not in your book? X will become our what? Compare it with the question you're giving. What will X be? Is that not so? Fantastic. What is going to be the V? You say? Exponential x dx. Is that not so? Is that not so? The function says the integral is integral u dv. What do you have here? You have x. The remaining is what? Exponential x dx. So from here, if I integrate this side, I'm going to get what? V. Is that not so? Is that not so? Yes. Good. Then if I integrate this, let me do it separately. So I want to integrate here. I'm also going to integrate this place. So if I integrate here, what am I going to get? V. Because this is integration is anti-differentiation and vice versa. If I integrate here, what am I going to get? Integrate exponential x, I'm still going to get exponential x. Now, from here also, I can decide to differentiate this side. Right? So it means that the x is still going to be what? du. If I differentiate both sides. Is that not so? Is that not so? Fantastic. So in my formula, what I'm looking for is what? I'm looking for u, I'm looking for v, then I'm looking for du. Is that not so? Is that what I'm looking for? Fantastic. So substituting into that formula, what am I going to get? What is u? U is what? U is what? U is x. So I have x. What is v? Exponential x. Exponential x minus integral. What is v? Exponential x. What is the u? What is the u? What is the u? Dx. Dx. So this part of the integral, I am done with it. Integral of exponential x dx is what? Is what? Is exponential x. Fantastic. Very simple. Then you can add your constant of integration. Constant k. That's all. If you like, you can take it a step further. I can factor out exponential x here. Is that not so? So I can have exponential x into what? X minus 1 plus your constant. And that is that about that. How simple is this? Are we together? Who does not understand? Who does not understand? You say? Okay. The idea of integration by part is that you are given two functions, right? The functions that you are given, they are in product form. When I say product form, it means the operation in between these two functions is multiplication. Are we together? You are supposed to multiply these two functions. Now, we have derived from product rule that the integral of the product of u dv, which is here, is equal to uv minus integral of v du. We have proved this earlier on in the previous classes and also in this class by product rule. The difficulty here now is your choice of what? U and V. The difficulty here is your choice of what? U and V. For instance, this integral is given in the form x exponential s dx. Is that not so? Is this not product? Good. This thing is not the same thing as exponential s multiplied by s dx. Is it not the same thing? Now what we are saying is that you are supposed to compare this with what? U dv. Are we together? Because the formula that we have says that integral of uv is equal to uv minus integral of v du. Are we together? Now, you are supposed to compare, so that means I'm taking x to be u, and I'm taking the whole of this, are we together, to be my what? dv. Do you understand? That is what we have done. So we took u to be x over here, and then similarly, we took the whole of this guy, the whole of this guy to be our what? Our dv. Now, when we do this, after a single integration, right? After a single integration, we got our answer to be this, because we just substituted. We have the v is equal to exponential x. When you integrate this part, we're going to get v. And integrate this part, we got exponential x. We differentiated both sides to get the x here and then the u over here. We substitute into our integral. We have u. This is u. We have v. This was our v over here. We have the integral of v, then the u. The u was the x. We substituted and then we integrated this part also to get exponential x plus constant k or c. Whatever your constant may be, constant is always a what? A constant. And I say you can go a step further just factoring exponential x outside. But had it been we pick our u to be equal to exponential x and dv to be equal to x dx, we may fall into trouble. Because one of the integral may not terminate. Do you understand? But you can try it. For instance, let's try it together. See, just watch. If I had arranged this in this way, my u is going to be what? You said? Fantastic. It's going to be exponential x. And then my dv is going to be what? Fantastic. S dx. This is u. And then this is what? V. So look at this very well. If I want to get v, I'm going to integrate this side back. So if I integrate here, what am I going to get? If I integrate here, I'm going to get what? V. V is equal to what? If I integrate the other side, I'm going to get what? I'm going to get what? What will I get if I integrate x? X squared all over 2. Is that not what we say? If you want to integrate x 1 plus 1 upon 1 plus 1, is that not so? Good. dv du over here. If I want to get du here, what am I going to do? Huh? The idea here, in fact, stop this. Let's pause this. Okay. I will explain this thing one more time. Two functions you are giving, they are multiplying each other. These two functions are multiplying. Whatever you can integrate, use one divided by what? That's what we are doing here. And to do that, we go and employ the formula. The formula says integral of u dv is equal to uv minus integral of v du. Now the idea is from product rule. That's where we got this. Is that also fantastic? Now, the function is ln x dx. We are going to let all this guy over here, this guy you're seeing over here, to be our what? Our u. We're going to be letting the x to be equal to the v. So it's obvious that your u is ln x. If I decide to differentiate u, I'm going to get 1 over x dx. Because the u dx is just 1 over x, which we have established that before now. Now, what is dv? dv is the same thing as the x, which means if I integrate both sides, I'm going to get v is equal to x. Now, I have all my variables. I have u, I have v, I have u, I have the u, and I have the v. I will just go and substitute it into the formula. Now, substituting it, I have u. U here is what? In x. V is what? X. Right? My v also is x. Then du. Du happens to be what? 1 over x dx. Fantastic. So once you substitute, you don't have the integral over here. So you just evaluate this part. But you have another integral here, you must take the integral. Do you understand? So, but x can go with x, you are left with the x, you integrate it, you have x plus a constant k. And it becomes simple. All you need to do is to factorize. In fact, if I am your examiner, if you stop here, I'm going to mark you. Do you understand? But you can go a step further just to factorize. Simple. Quite easily done. Good. Now, from this concept, right, this is similar to this. Is that also? Right? This is similar to this. So what's going to happen? We can use the same concept. Is that also? So which means we can let our u to be equal to what?
X squared.
Fantastic. X squared. Then we can let what? Our dv can be equal to what?
Exponential
X dx. Right? See, let's do it together. What we have is what? Integral of exponential x multiplying x squared, then dx. Are we together? We now say that let your u be what? X squared. Then the v automatically will become what? Exponential x dx. Differentiating u with respect to x, you're going to get what? 2x. Which means is 2x dx, and then v is exponential x. Why? Because when you integrate the v, you're going to get what? V. When you integrate the v, you're going to get v. Similarly, if I should integrate here, if I should integrate this function, I am supposed to get u back. Is that what we say? Which is true, because we have 2x. If I integrate it, I have 1 plus 1, which is what? 2, divided by what? 2. Can't you see? So I'm going to get u back. Now, all I need to do is to substitute it back into the formula. What's the formula? VU, UV, VU, commutative. You can multiply them. What do we have? Exponential x and multiply by what? X squared. So the first part of that integral is what? X squared multiplying what?
Exponential x.
Fantastic!
50.
That is what I expect you to write first. Minus what? Integral of what? Exponential x multiply what? Du. Du is what? 2x dx. Do you know why I gave you guys this one? Because you have done it here. See, this is x squared exponential x minus. I can pull out these 2 is a constant, right? This is what? Integral of what? X exponential x dx. It becomes this integral. It becomes what? This integral. What are you supposed to do to integrate here again? Another integration by parts. How do you see math is simple? So to integrate only here, I must use another word, integration by parts. So if I integrate here, my u is going to be what? Here, u is going to be what? It's going to be x. The v is what? Exponential x. The u is going to be what? Dx. Then v is still going to be what? Exponential x. You see how much is simple? Just to integrate here. So finally, I'm going to have x squared exponential x minus 2 into uv x exponential x minus integral v exponential x du dx. So let me put this one over here. So finally, I'm going to have what is integral of exponential x? Fantastic! Exponential x plus k. You can decide to expand it. You have x squared exponential x minus, here you have integral, not integral again, you have x over here, exponential x over here into, what do you have? X minus 1, right? Your 2 is here. Then you can decide to close this one plus c. Is math not simple? Is math not simple? All you need to do, you do it again. I didn't mean you did not finish. You still do it a what? Again. Do you understand? Who is confused? Nobody.
Sir.
Why are you confused?
Sir, like this TV, like as you're arranging it.